Now, next topic is about services. What is a service? What is a service, team? We talked very briefly about what is service, why services. Do you remember? Yes, Vishal. Yes, team. Now let's understand that this is your parts. Hope I'm audible. Team, I'm audible.
Yes, Chaitanya.
Okay, sorry. So let's consider that. So what happened to you for the lab?
So I'm a bit this one in the middle, Chaitanya. So I was about to read the document and follow. But anyway, I'll catch up later offline on this thing. No issues.
Okay.
Yeah.
Now let's consider that you have an application. So this is your parts. And these parts would go down and come back. So many things would happen. And when they go down and come back, when you stop and start or restart, yeah, I'm talking about when any restarts happens, when any health check fails, it will restart it. So the IPs changes. So we want to have a better mechanism for managing these parts. This is where we use a service. So service is a abstraction wherein you directly don't log into the parts. You would access the parts using a service. Yeah. What I'm saying is, I will first create a parts and then create a service with the same labels. And this gives you a static IP. And to access the backends, I would use the static IP of my service. Okay. So let me give you a simple example in the lab so that you are back to track. So in this example, I want to access the applications using a service. This is your deployment. I created one deployment. Now I want to manage this using a service. So I'll say service, and I would use the same label. So this is your deployment with the same label. So it will go ahead and create it, the pod, and the service would have a static IP. And this is the pod IP. Now, how do we test it? For example, once you do you go to the worker node where it got created, and you can try to access that application using a service web IP. Yeah. So first you create deployment, then you create a service. You observe where it got created, which worker node it got created. No. I'll explain you this while doing the lab. I think I have 2 labs for this. So in very brief, what we are saying here is first you create your pods. Create the pods. Next one, you map this pods to a service. Then if it is an internal service which you created, you can go to the worker node. Yes, you can also work from other worker nodes. Sometimes you'll have some challenge. Any worker node you can go. And when you try to curl using the service VIP IP, IP, it must give you the application which is running in your pod. Yes, are you able to understand?
Yes, Chaitanya.
So there are different type of services. One is a cluster IP service, where you access them only through internally. And the other one is a node port. So node port, we use it when you want to, so let's consider that you want to access the application, which is internet facing. So we can assign some ports. So we can assign, not sure why is this pen is not connected. So we can assign some node port, a common port across all of them. And this application will reach from either this machine or this machine or from this machine using a public IP of the box along with the port number. So what we're talking about in the example is so node port. So let's consider that if you have onto an application to be accessed, so either we normally allow 80 port or some port to be accessed from the host, but these ports could be occupied for some applications. So Kubernetes gives a range between 30,000 and 32767. They give a range, and this range, the port, is common on all the worker nodes. So if you say that I want to assign like 31 here, and any application is there, once I create it, I can access the application using a public IP of worker 1 and the port number, or I can use the public IP of the second worker node and also get the information. For example, in here, this is your port numbers. So we can have the same deployment. And now I would say that I want to access the application using a node port number. Now, when I do this, you're going to create your service, and I can access the application on both the worker nodes. That is a node port. Also on the master, you'll be locally able to do it, but something doesn't work. On the master, it must work. So node port is going to give you some IP addresses and a common port using which you can access the application. Are we clear?
Chaitanya,
Yeah.
this cube DNS is the one who will resolve the IP conflict during what you call reset of any of the node. Means like,
code DNS.
Yeah, sorry. Yeah, DNS.
Okay, what are you asking?
Like it is the one which is responsible to what you call assign the IP if it goes down.
Yeah, you're right.
Automatically.
Yes.
Okay. Yeah, fine. Thanks.
The second option. Third option, what we can use is like a load balancer. So load balancer could also be used. And you can come to load balancers, could be of load balancers of cloud, like application load balancers, Azure load balancers. Or we also have Nginx, which is an open source load balancer also we have. Yeah. So let me give you some more information about all these things.
But before that, the nodes has to be registered with the load balancer, right?
Yeah.
Yeah, okay.
So those things we are not getting to here.
Okay, no issues, no issues. Just an thought I thought.
Yeah. So I'll explain you that. So now we all can talk about. So first one is a cluster IP, node port, a static port number. We can use load balancer. And if you also want to append a CNAME means instead of having an IP addresses, you can give in some human readable names. So node port is between this range and this range and assign. And how we mention that? So you say create service, type is node port, give the same label names as what your port you had. Ports, target port, which is on your node. This is on your application running on your container. This is a node port which you want to expose. So once you define this is one. Other type you want to use a load balancer. You have to define from where the traffic is coming for load balancer. So all these are a type of cluster IPs. But again, on top of cluster IPs, we can have like a node port, we can have load balancer, all this could be configured. For load balancers, we can use cloud load balancers, Azure load balancers. These all you have to configure it, and then you have to integrate it.
Okay, Chetan, I assume that cluster IP is an entry point to the system, right?
Yeah, that's the entry point, the default.
Okay, thanks.
So for example, now how it is working. So there must be some method of communication which is happening in your cluster. So they are, as of now, when you do a get SVC, you would see a default service, cluster IP.
Yeah.
So using this service, your Kubernetes API server and all the components are getting communicated. You can do a describe of it, and you see it is happening between the service port. So you can create. So how do you start? So let me create a deployment. kubectl, create. Again. So now I'll say get pods -L, which had the label as Linux. Okay. So now I want to map this to the service. So now we want to add this to service. So we would add a service. The same label name selector. So in the YAML files, this is a session for your pod, this session for your containers. So we are defining the same label. This is your service details that it has to match. It has to give the label of this. And this is going to get mapped to the pod container. So now I'm going to run this. It got created. So now I do a get service -l app equal to nginx. Yeah. So now I can do a describe svc nginx-svc. So 10.4.0.2 is your pod IP. Are we clear till now?
Yeah.
So we'll observe where it got created. So I'll go to the worker node 2. And do a curl. Okay. It is able to reach the application. Now I go into worker node 1. It must, but we had some challenges. Okay. And when I also do a curl, this is not working for some reasons. So this is how we can do a cluster IP. Yes, team. Are we good?
Yes.
So testing part are not done. It's testing part as you can go and put into those specific worker nodes and do a test. Yeah, please play around. And what doing in here is, if I scale up, same labels, all those 3 things, for example, all will add it to the same service. You can scale up and observe all of them because they're all using the same labels. Rest of it. You can do both the labs, lab 1 and lab 2. Yes, team. Any questions?
No, Chaitanya. It's having some issue with the internet. Kicking out.